Alright, we're going to start on this lab on counters, our second counters lab. And this one we're going to go use a CMOS IC. So one of the 4000 series. I actually have the pin out at the bottom. It's the 4027. It's a dual JK flip-flop. So the first thing we're going to do is just connect this on the trainer and test the JKs. So I want you to just go through here. I have the truth table for the JK flip-flops. You'll want to fill out 4 of them with the clock rising. I believe it's a positive clock. Double check it. Yep. And then the other 4 will be based on no clock, so you can just talk about the status quo. Now, before we get this going, you want to go look up power. I do have this pin out, but I'll be honest, you probably want to look at pull up the data sheet too. VDD is the positive, VSS is the ground. So power gets listed a little different on these, but it's still 5 volts and 0. So I went ahead and put this chip on here. I've got these, I'll come back to them, but down here I have ground, up here is power, just like our standard 7400 series chips. So what I'm going to do is we're going to test the top JK flip-flop. We're just going to test it and make sure it works. And you want to do both. I'll just do the one for now. But set and reset are 9 and 12. I've connected them with these 2 black wires. Okay, now this is an active high set and reset, unlike the 7476, which is active low. That means if I put set to plus 5 volts or put reset to plus 5 volts, it will do either of those asynchronous controls. But if I want to just work in normal mode, I don't want either one of them, so I'll put them down to ground. So this actually works the opposite there, that the 7476 was active low and had a low input clock. So here I'm going to connect these to ground, and that eliminates their usage for this. Okay, now if I take a look here, the first one looks like J and K are 10 and 11, and Q naught are 14 and 15. So I'm going to put J is, I'll use A for that, and I just said J is number 10. I'm actually going to cross these over, and K is number 11. So there I've got J and K. Q is 15. And Q naught. And finally, I need a clock. So clock is number 13. So I'll have every connection up here. Again, I have J and K here, Q and Q naught, clock is in the middle. It's a little more logically laid out. Okay, you can see it's in toggle mode. So JK, 0, 0 should be hold, so should just hold this. 0, 1 will set Q to 0. I guess it's not going to do anything else because we're already there. 1, 0 should change them. You can see it's at 1 hertz. Go back to 0, 0 should hold it. And the JK 1, 1 is toggle. So if I'd like to try out the other side, I can go through and put set, which is 7, and reset, which is 4. 1, 2, 3, 4, and 7. Connect both those together, and we'll connect them both to ground. So that should mirror what I have here. Well, a very long ground, but I'll go ahead and use it. There we go. J and K are 5 and 6, so I'm just going to take these down there. Q and Q naught are 1 and 2. It's not going to work yet because I don't have a clock. And 3 is the clock, so I'm just going to take a little short green and jump up over the top so I have a clock. Okay, set to toggle. Let's try 1, 0 should be 1, 0 is hold, 0, 1 should go back to 0. Zeros hold. So it looks like I tested both sides of the JK, both JKs, and it's working. That's what I'm going to do before I go on. Now I go to the second page, and I'm going to build a 2-bit counter with this. This is going to be much like our other counters we've done. I have a picture here, and it's kind of a shortcut. This shows these as toggle flip-flops. T tied to 1, saying to toggle. What we can really interpret that is, I want to have my J and K's connected together into 1 because that's toggle mode. So what I'm going to do is I'm going to take the JK's on both sides of this. So in one case, it's look back. It's 5 and 6 right here. In the other case, it's going to be 14 and 15. Okay, I'm having troubles with this one. It's kind of small. It's easier if I had a little pair of pliers. Those ones are easy to slide in and out with pliers, but I don't have any sitting right here. Alright. Up here, so my J and K's are linked. Now I need them all to go to 1. Oops, they were linked, but I pulled that one wire out accidentally. Grab one just slightly bigger. So I'm just going to hook it straight into my power. Either one of them here. Okay, all those should be positive, and now I want to jump a little one over the top from this JK combination to these. I'll leave my clock in here, the green one. Okay, before I go on, I'm just going to check and make sure those are all 1s. It'd be pretty easy to mess one of these up, so no reason to go on until I've checked them. That's why I have the extra. Get rid of those wires. Okay, so I've connected all my J's and K's to positive. I've got my sets and resets to ground. I'm already preset. Now what this shows right here is I can do this one of 2 ways. I can either go out of Q through an inverter into the clock of the next stage. So this is an asynchronous clock. I'll get rid of that clock. And instead, what I'll do is I'll pull that clock out of Q0 of the previous stage. So if I make the top JK flip-flop my first stage, I'll take 14 and run it into the clock of the second stage. Oops, I messed this up. J and K were supposed to be over here. 10 and 11. I don't know what I was thinking. Obviously it wasn't right. Or my outputs I was hooking up. Okay, there we go. And now I need to take that to positive. I could jump it over to the positive. I could also just link it straight up to the positive thing above. Either way will work. Okay, there we go. Now we'll take my Q0, which is 14, right here, and I'll run it into the clock of the next stage. And I'll take Q here. Right now, this should just be going with the clock signal. There we go. And I take Q of stage 2, which is right there. 0, 1, 2, 3. I built my asynchronous counter. So I've just constructed this. I used those 2 D flip-flops. D flip-flops, sorry, JK flip-flops. I made this counter work. Now my next step is to make it a down counter. So the way I make a down counter is I take the Q instead of Q naught out and run it to that clock. So my clock here, rather than coming out of Q naught, will go here. So we'll see. We'll go 0, 3, 2, 1, 0. So I built my count up and count down counter. My next stage after this is to take another 4027 chip. I'll put it right here. I'll connect power the same. I'll connect all my sets and resets to ground. I'll test them all as I go. I'm not going to do this for you. I'm going to let you work on this. We're at lab 12, so we should be okay to do this. So I'm going to take my logic probe and test it as I go. In fact, if I need to, I would even test both sides of the JK first, just to make sure it's all working. But then I should be able to build a 4-bit counter. This is going to look just like my initial counter, where Q naught feeds the clock of the next one. I got all 4 working. It should count 0 through 16. Then I want to do the 16 through 0 down counter. So all I got to do is take all those outputs that were at Q naughts and connect them to the Qs. So now it should count down. What I'm going to do then is add an AND gate, so I have a mod counter. So what will happen now is I'll count 0, 1, 2, 3, 4, 5, 6. When I'm at 6, Q naught's a 0, Q1's a 1, Q2's a 0. Or I'm sorry, 1. Right, that would be a binary representation of 6. But these two values are 1s, so the AND gate becomes 1. I send that out to all my resets. So my resets no longer are connected to ground. I leave my preset to ground, but my resets now are connected to the output of this AND gate. So that means I'll need 2 4027s plus an AND gate chip going. I'll use 3 JK flip-flops. Rather than, again, my sets need to still go to 0, but my resets I can run so that they'll trigger off this AND. So what will happen is when I get to 6, those are both 1, it will reset. It resets everything to 0, so we'll start over. So now I have a modulus counter. Rather than always counting up to 8 with three of these toggle set flip-flops, now I can count some value less than 8. What we'll do then is we'll add that 4th JK flip-flop back in, and of course you'll have those 2 chips already on your board. So, and make the AND gate connect to Q1 and Q3. So that means, and by the way, this looks backwards, right? This is Q naught, this is the least significant bit. So we'll have 1 0 1 0, which is 10. So when we hit 10, we'll reset everything. So that means we'll count 0 up through 9, we'll go to 10, and we'll reset. There might be a little flash of lights as you slip past that, but hopefully not. We use the CD 4081 for the AND gates, just so we get used to using some of these CMOS chips. So we'll have 2 of them, so you get to learn that in addition. Now, your next one is you're going to use the 4 counters and make it into a mod 12 counter. I want you to think how you do that, right? You're going to get up to 12. Figure out what 12 would be in binary. Make sure you run those through your AND gate so it resets. And you'll be done at that point. So, good exploration of the CD 4000 CMOS chips, ICs, a little different we've done, and some counters, count up, count down, and mod counters for you to explore in this lab.